Alright, so we're going to be looking at the arrays and hashing valid anagrams problem from the NeetCode Roadmap. And so today we're going to be trying to solve the problem given two strings s and t. Return true if t is an anagram of s and false otherwise. So the formal definition here is an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. So essentially we have these two words here, and if you had the count of each letter from each string, you'd realize that they would have equal counts for every letter. So for example, there's there's three A's here, and there's three A's here, and then the other letters each have one letter. And the thing is, here is a counterexample of what an anagram is not. So we have rat, one R, one A, one T, and we have car, one R, one A, but one C, and so that's why they're not anagrams. So we'll go into the explanation here now. Okay, so to preface this, we're going to be using a slightly different method than some others, but in the end we'll ultimately get an understanding of how to solve this problem with some intuitive background. So let's say we have an example string s equals r a t and t equals c a r. And so I'll start off by saying this, and I'll re-explain it after I finish the whole problem. But we're going to be storing things in a list, and this list will essentially have every index represent a letter of the alphabet. So here we'll have s underscore dict and t underscore dict. And so each of these, we're going to be setting them to 0 times 26 and 0 times 26. And so what this ultimately becomes is 0, 0, 0, dot, 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 all the way until we get to 26 zeros for both of these dictionaries. And so next we're going to go over how we're going to fill up this. Okay, so now that we have a method to store the values, I need to go over a very important concept and function that is built into Python called ord. So what ord does essentially is it takes in a string and it'll map it to a numerical value. So for example, ord of a lowercase, because this is case sensitive, will map to the value 97, I believe. And so this will be linear. So if we do ord of b, this would map to 98, and then so on and so on all the way down to z. And it, of course, it's not limited to z. It actually, I think it keeps track of every Unicode character, but if not, correct me. So now the next question we ask is, what is ord of a? Oh, sorry, what is ord of d minus ord of a? So from this table over here, we can tell that ord of d would be 100 and ord of a would be 97. So 97 or 100 subtracted by 97 equals 3. And so why this is significant is because if you take a look over here, right? So let's suppose that this list that I created here goes all the way up to 26, right? In this, the length of this array here will go to 26. So we can directly map each letter of the string. For example, here we can find this letter where it goes into this array by subtracting letter by the letter, or by ord of a, since that's the starting point. And so for example, we can tell that let's say the string is d a d, okay? So we index over every single letter here, and from that we would basically every step we take ord of d, so ord of d minus ord of a, And what does that equal? 3. So then we can map it to 1, 2. Oh no, sorry. 0, 1, 2, and 3. And so we know D would go right here. So this would be increased to 1. And then, since we increase it to 1, we now know that there's at least one letter here. And then we would do this for both the strings, and essentially in the end we would compare those two lists. So we'd compare these two lists, and if they're equal, then we can return true, otherwise false. And the reason that I don't do this with a dictionary, like a pure dictionary like the built-in one in Python, is because you actually cannot compare two dictionaries in Python. But there is something called counter, which would essentially make this problem very trivial, and that's why I didn't go over it like that. So let's get into the algorithm. So essentially, let's get into the algorithm. So basically what we're going to be doing is, for both strings, RATCAR, we're going to have, of course, the list as I mentioned here, but also we're going to check beforehand to see if the length is even equal, because if the length of the two strings aren't even equal, then there's kind of no point in even bothering with this loop, because we know that two strings of different length cannot be anagrams. So then after doing that, we're going to essentially loop over this. So we're going to be looking here, right here. So is ord of R minus ord of A, or this is not a question actually, sorry, but we're basically at every step we're going to be taking ord of R and then, or ord of this value, and then subtracting by ord of A, and then we're going to take ord of C, and then subtracted by ord of A. And so from this, we can tell that this would equal 99 minus 7, or 99 minus 97, and then this would equal, let's suppose it's 112 minus 97. And then so we take that value, so this value, if I simplified it, would be 2, and this would be 3, 5, 15. And so then we would take this value and put it into the index associated with it, and add 1 to that value, to that index. And then we take this value and then find the index for it in this one, and then add 1 to that index. And then we would keep going up all the way up to the end of the list. So like this, check here, check here, check here, and then of course the list will terminate. And then at that point we would basically check if the two lists are equal and then return. Okay, now let's get into the solution for this. So again, I said that we're going to check if the len of these two strings don't equal off the bat, because if they don't equal, then we should instantly return true, because that would mean that they're not an anagram. After that, we need to store the things in dictionaries, or dictionary-like lists, so dict s and t dict. These equal 0 times 26, and then 0 times 26. I'm doing in this syntax, it's really just equivalent to this, so s a dict equals 0 times 26, and like this. These are really the same, except like essentially for this function it's the same, but there is a slight difference to it. But yeah, essentially this is what I'm doing. It just saves me a line. And now that we have this, we're going to iterate over the list, or iterate over both strings. So for I in range of, you can pick either letter, but I'm gonna pick S, because these are both the same string, or same length string, so we don't have to worry about going out of bounds of either string when we're iterating over them. So then for I in range of len S, we're going to check if s of I, and then the ord of this minus ord of A is, sorry, we're not actually checking. We're basically going to be taking the string, the ord of the value at the index of s, and then subtracting by ord of A. And then we're going to be putting that and adding this value to the index of s of Dick. And then, sorry. Let me repeat myself. So, essentially what we're going to be doing is taking, for every value in the string, we're going to be adding 1 to the value of s of dict at that certain index. So, plus equals 1. So, at the index of ord of s of dict, ord of s of I minus ord of A, we're going to be adding 1 to that. And then so same thing for the t dict, so t of dict, and then at the index of ord of t of I, we're going to be subtracting ord of A from that, and then adding 1 to that index value. Lastly, we're just going to return if s of dict equals t of dict. And if these two are equal, then we know that we have an anagram because the lists should both be the same. And if not, then we know we don't have an anagram. And if I hit run, hopefully this is good. Nice. And so we have this solution here. Oh, sorry, that's another person's solution, but yeah, the time complexity is the same. But if you want to see the counter solution, which is very trivial, you just basically return this, and this is almost like returning, so counter of s is basically generating a dictionary, but instead it sort of keeps track of an order of how things go. So like, it's sort of like a list with a dictionary. But yeah, that's kind of how they did it.